Hi, welcome to my channel. In the previous video, I discussed about the KNN classifier algorithm. KNN classifier algorithm. In this video, I am going to explain the KNN classifier using the iris flower dataset. That means iris flower classification using the KNN classifier algorithm. So in this, we are using the iris flower dataset. Iris flower dataset. It contains four features: sepal length, sepal width, petal length, and petal width, and the corresponding species. There are three types of species are there: Iris setosa, Iris virginica, and Iris versicolor. It contains 150 rows are there, 150 rows and 5 columns. That means four features and one class label. So these four features are called as a X and this is called as a Y. Okay. Now we are going to classify the iris flower by using the KNN classifier. In the machine learning, we have to follow different steps in order to perform the classification algorithm. Okay. So here the first thing is understand the business problem. Here the understanding business problem in mathematics, you have to classify iris flower dataset. Classify iris flower dataset. That is your problem. And here the next step is we have to collect the dataset. So according to business problem, we are going to collect the dataset of iris flower from the GitHub or Kaggle or normal Google. Also we can find out the dataset. Now we are going to perform the pre-process dataset. Now here the dataset contains 150 rows are there. Contains 150 rows and 5 columns are there. 5 columns. Sorry. 5 columns are there. It contains 5 columns. Okay. And sepal length, sepal width, petal length, and petal width, and the corresponding class label species. Okay. And it contains 0 to 149 elements. Now, if what do you mean the pre-process? Pre-process means if any column data is missing, in the given data set, we have to represent some value by using the maximum value or minimum value or average value. Like there are different approaches are there. Based on that approach, we are going to replace the missing value and find out the some data. Okay, pre-process data set. This is called as a pre-process. Okay, then split the data into training data and testing data. So here we are going to divide the data into out of 150 rows. We are going to split the data into two parts. One is a training purpose, and one is for the testing purpose. Here each and everything is divided into four parts here. Okay, that is X train. All the features of the all the features contains X train. X and this is called as all the features are called as X and all the corresponding class labels called as Y. So here the X train is contains the 70% of data is for the X train and the corresponding class label is called as a Y train. And whatever the remaining data, 30% of data is assigned for the X test data, X underscore test data, and corresponding class label is Y underscore test data. Okay, like that we are going to split the data into two parts and then develop your model. Here the model is a KNN classifier. KNN classifier, K nearest neighborhood classifier. And then we are going to train the model using our training data. So here the model is a KNN. For this model KNN, we are going to train the model with respect to our training data. What the training data? It contains X underscore train and Y underscore train. The corresponding features of training data and corresponding class label of the Y training data. And then test the model using the test data. Okay. So that is a KNN data predict of based on the one you are providing the X underscore test data. Based on the X test data, we are going to predict the Y cap of predicted data. Okay. Now we are going to evaluate the performance of your model. So here Y test is data is there, that is called as a actual data test, and Y underscore predict is called as a, we are going to differentiate between the Y underscore predicted value and Y underscore test value. This is Y underscore test value is called as a actual data and this is called as a predicted data. If there is any difference between, okay, we are going to find the performance based on the Y underscore predict value and Y underscore test value. Like that we are going to find out the performance of the our model. Now this can be seen by using the Jupyter notebook, okay, with the code. So here it contains three flowers are there: Iris Setosa and Iris Virginica and Iris Versicolor. Now I am going to see the code implementation of this KNN classifier using the Jupyter notebook. Okay. Now here it contains the different steps are there. Already we discussed that one. First of all, you have to import our library files like import numpy, import pandas, okay, and our model is K neighbors classifier, and that is you have to import from the sklearn dot neighbors import to neighbors K neighbors classifier, and from we are going to split the data set. Okay, further we require the from sklearn dot model underscore selection we are going to import the train underscore test underscore speed, and then from sklearn import metrics to find the performance of the model. So the first step is you have to import the data set from the our model. Okay, so here we are using I'm storing our data set in my Google Drive, so that's why I'm connected to my Google Drive. Okay, from google.colab import to drive.mount. I'm going to drive the mount it, okay, with my drive, and file path equal to content slash underscore drive slash my drive slash iris.csv. So here my iris flower dataset contains in stored in the my drive. From that we are going to import our data set. Okay, so now the next step is we are going to read the data set. Okay, so our data set is located at content slash drive slash my drive and slash iris.csv. So that file path I am provided here. From that file path we are going to read the data set that is stored in the data set. Okay, now I am going to display the data set. Okay, top 5 rows of the our data set. So here sepal length, sepal width, petal length and petal width, the corresponding is class labels. So this is about the data set description. Now I am going to display the data set. Okay, the data set is contains 150 rows are there, 150 rows are there, and 5 columns are there: sepal length, sepal width, petal length and petal width, the corresponding species. Okay, so it displays the top 5 rows and the top bottom 5 rows for the description purpose. And then data pre-processing. Okay, I'm going to find out are there any missing value in the data set or not. So here the sepal length contains 0 null values are there, sepal width also contains 0 null values, and petal length also contains 0 null values, petal width also contains 0 null values, and species also contains 0 null values. That means there is no missing value in our data set. So here I'm going to display the data set to describe, data set dot describe. So it shows the all the important features of the corresponding features. Okay, so sepal length, what is the minimum, what is the mean value, how many count, what is count, how many elements are in the sepal length, how many elements in the sepal width, how many elements in the petal width, how many elements in the petal width, like that everything is counted. So 150 means there are 150 elements in the each and every column. Okay, mean of the corresponding column, standard deviation of the corresponding column, what is the minimum value of the sepal length 4.3, minimum value of sepal width is 2.0, petal length is minimum value equal to 1.0, petal width of the minimum value equal to 0.1, and like that we are finding out the maximum value. So this describe the everything of the count value, mean value, standard deviation, minimum value, 25 percentile data, 50 percentile data, 75 percentile data. Okay, so like that we are getting the everything for the given data set. So now we are going to divide the data into two parts, x and y. X is nothing but a features and y nothing but a class label. So here x is equal to dataset dot allocation, all the columns, okay, sorry, all the rows. The first column means all the rows followed by comma, okay, colon minus 1. That means except the last column, all the columns are assigned for the y, sorry, x. Okay, x contains all the features. The next y equal to, it contains only the last column, that is a features class label only. Okay, that is equal to dataset dot allocation, all the rows followed by comma, okay, minus 1. That means that the last index value that is contains class labels that is assigned for the y label y. So that means here by performing this statement, x contains only features and y contains only class label. Now here we are going to display the x value. So x contains only sepal length, sepal width, petal length and the petal width of the all the 150 rows. And y contains the class label. It contains all the 150 rows of the corresponding class labels. Now we are going to display the top head of the training data. Okay, sorry, x data. So print x underscore x dot head. It displays the top 5 rows of the x values. Okay, sepal length, sepal width, petal length, and petal width. And it displays the x dot info. X dot info shows the how many are there any null values in the data? What the data type of the corresponding features? Okay, how many elements in the corresponding column? Okay, so sepal length contains 150 rows. It is not null, and the type of that one is a float 64. So petal width also contains 150 rows, 150 values. All are not null, and it contains 64. Like that, it displays all the things. So here, all the features contain the values. 150 values are there, and print dot y dot print of y dot head. It displays the top 5 rows of the class label. Setosa only. Now it displays the y dot info. Y dot info shows it displays the information of the corresponding class label. Okay, here it contains 150 rows and all are belonging to non-null, and the type of data type is object type. Okay. Now after that we are going to find out the split the data into four parts. So further we require the from sklearn dot model selection import train underscore test underscore split. Okay, so that is divided into 4 parts. X train, x test, y train, y test equal to train underscore test underscore split. For this function we are providing the x nothing but features and y nothing but your class label, and the test size equal to 0.30. That means 30% of data is assigned for the testing purpose and 70% of data is assigned for the training purpose. Okay, now if you display the x underscore train underscore info value, okay, it contains 105 rows are there. 105 entries are assigned for the x underscore training purpose. Okay, and all are not null values. X test contains remaining 45 rows are assigned for the test purpose, and like that y train purpose 105 rows are assigned for the training purpose, y class labels, and y test contains 45 entries. Okay, 45 entries. Now we are going to build the model. Our model is KNN classifier. So we are going to get this one by from the class sklearn dot neighbors dot k neighbors classifier. This can be found by found in the Scikit.org. That is one organization is there that shows all the APIs of our models. So here all the machine learning models are placed in the Scikit.org. Okay, this is one type of software learning algorithm. It shows all the implementation done here. Okay, it provides what are the different parameters are there. Everything is going to see here. Okay, so our model is a k neighbors classifier, and that is from the class sklearn dot neighbors. Okay, so it contains different parameters are there. N neighbors equal to 5, and star weight equal to uniform, algorithm equal to auto, leaf size equal to 30, p equal to 2, matrix equal to Minkowski, metric parameters equal to none, len jobs equal to none. Like that, where every parameters are defined here. Okay, here in the following by it displays describe each and every attribute, n neighbors, and what are the weights are there, and what is the algorithm are going to use it here, what the leaf size, and everything you are going to see here. From that we are going to implement our model. Okay, now here we are going to select our model from the KNN classifier from the scikit-learn dot neighbors. Import our class level. Our model is k neighbors classifier. So KNN equal to k neighbors classifier of n neighbors equal to 5. So then the number of neighbors are equal to here 5. So now here the next step is you have to train the model. So classifier equal to, we are going to assign the name as a classifier equal to KNN dot fit function. So in the KNN, we are going to, based on the KNN, we are going to train the model. So for the training purpose, we are using the fit function. KNN dot fit of x underscore x train and y train. So that is the x features and the corresponding class labels of the training data. So based on the training data, we are going to train the model. Then we are going to test the model by using the predict function. So our training model is a classifier. Classifier data based on the training model. Okay, based on training model, classifier data predict of x test data. For the testing purpose, we provide the only features of the x test data. Okay, based on the x test data, we are going to predict the new value. That predicted value is called as a y predicted value. Now we are having the actual y test value is there. Actually we are having the y test value is there. So we are going to find the performance of the model based on the y predicted value and the actual y test value. So to find the performance of the model, so we are going to import the metrics from the sklearn.to metrics. So import to sklearn.to metrics as a matrix. We are going to create a matrix called as a confused matrix. So metrics data in that matrix we are having the confused matrix is there. So here we are having you have provided two variables. One is the actual value and the predicted value. Y underscore true value equal to y test value. Y underscore predicted value equal to y predicted value. So from that we are going to display the confused matrix. So here it displays the confused matrix. It shows that the row side contains the actual values and the column side contains the predicted values. Okay. Here there are 45 elements are there. In the 45 elements, 16 elements are belonging to class label Setosa. All the 16 elements are correctly classified as a Setosa only. And the second class label is called as a Virginica. Okay. So that Virginica is out of 13 elements. Okay. 12 elements are correctly classified as a Virginica and the one element is wrongly classified as a Versicolor. Okay, and also here in the third, okay, and two elements are wrongly classified as a Versicolor and 40 elements are classified as a Virginica. Okay, like that, this is it shows the confused matrix. Okay, of our data set. So now we are going to display the actual values and the predicted values, the original value and the predicted value. Okay, whether it is correct or wrong. Okay, so further we are going to display the one model, one table, I equal to 0, print of the empty line data lines, and print percentile of minus 25 as percentile of 25 as percentile of 25 as. Okay, and percentile original label and predicted label correct or wrong. So these three columns are going to display here, and then print the empty line data lines, and for label label in the y test value, okay, print percentile 25, percentile minus 25, okay, percentage label comma y predicted of y. For each and every predicted value we are going to use the colon, and if label equal to predicted of y, we are going to print the correct value, else we are going to print the wrong value. So for you have to increment all the 45 elements, I equal to I plus 1. Okay, it displays the output values. These are the original values, Setosa, and we are going to predict the as a Setosa value. So it is both are true. This is called as a correct value. So like that, we are going to display all the things. Now, based on these things, we are going to display our matrix report. So here, matrix dot classification report between the y test value and y predicted value. So it displays all the reports. Okay, it contains precision, recall, F1 score, and accuracy, everything. So the accuracy of the model is 0.93, and the number of samples are 45. So here, okay, the precision or recall F1 score of the Setosa is 1%, all are 100%. Okay, and here the number of support is equal to 16. The Versicolor contains 14 total number of elements are 14. Out of 14 elements are wrongly classified as a correct precision is 92%, and the recall is equal to 86%, and F1 score equal to 0.89. And for the Virginica, 15 elements are there. Out of 15 elements, the corresponding precision equal to 0.88, the recall equal to 0.9, and F1 score equal to 0.90. So like that we are going to find out the precision, recall, F1 score and accuracy of our models. So based on this information, our model accuracy is 93%. So matrix dot accuracy score underscore score equal of y test value and predict value equal to, if you display this one, 0.93, that means 93% of is 93% is our accuracy of the our KNN classifier model. Okay, like that we are going to find out the prediction of our model using the machine learning algorithm. Okay, in the Jupyter notebook or Python notebook. Okay, so this is about the KNN classifier algorithm. Thank you for watching our video. If you like the video, please subscribe.